Okay, good morning, everybody. Let's get started. I would like to start from welcoming you all at our winter 2024 SKCM² Winter School. So some of you traveled from overseas, some of you are local. No matter where you come from, we are very happy that you could join our winter school. And so since we have many people who might be first time introduced to our WPI-SKCM², I just want to very briefly tell you about our institute. So this institute was formed in 2022 as the world premier initiative institute, WPI program, the top program in Japan. And our mission is to develop knots as designable building blocks of matter or new atoms from which we will design and build matter material with unusual properties. With that, we want to establish a paradigm of knotted chiral matter and cross-pollinate topology and chirality knowledge across disciplines and scales, and also create foundations for technological innovation to address some of the most challenging global problems, including problems like climate change. And you can see from this diagram that pure mass plays a very important role in the ambitious project that we are trying to pursue, because it's a language that allows us to talk about the underlying physical underpinnings related to very different scientific fields, ranging from condensed matter and biological physics to planetary science and cosmology, and to subatomic matter physics and so on. In this institute, we have a cohort of PIs who join me in this ambitious effort. You can see here, most of them are from Hiroshima University here in Japan, but also from top research centers around the globe, such as MIT, Georgia Tech, Cambridge University, Max Planck Institute, and so on. And also we have a cohort of co-principal investigators and also affiliate members. So overall, we are about 170 members globally as of now. And among these members, very important members are graduate students and postdoctoral fellows who are part of this graduate program that we established here at Hiroshima University. So we know that knots are part of culture, many different nations around the globe. And here in Japan, these type of Mizuhiki knots are very popular because we are now approaching the Christmas and New Year time. You will see many such decorations everywhere. So you can see that here in Japan, public for perhaps over millennia was very fascinated by knots, but also we know that knots are part of many other cultures as well, and you are maybe representing these different cultures, so you would know perhaps even better than me. But of course, these type of constructs such as knots and multi-component links are also very important objects in pure mass and also in different branches of physics, where they can arise in different contexts of topology, such as, for example, models of subatomic particles in Stern-Witten model, where topological solitons can describe subatomic particles with different baryon numbers, and such as copions, as for example, the ones you can see here. And what's special is that recently these types of objects can be created in different condensed matter systems at will, and indeed they are found to exhibit particle-like properties similar to atoms and molecules, and as an example, you can see in here them forming gas states and crystallizing into crystals and exhibiting very fascinating properties of self-assembly into different crystalline lattices, such as closed crystals and open crystals. You can see in here, and including also triclinic crystals, which what's very special is that they can also be reconfigured by very weak external stimuli, such as low voltages on the order of 1.5 volts or so, can change the lattice parameters and reduce giant electrorestrictions. And here, perhaps this is just one example of how this designable knotted chiral matter could allow us to overcome limitations of the natural world, natural systems. Because in here you can see an example in this vivid demonstration by the video. We can induce giant electrorestriction of 50% or so, which is 2 or 3 orders of magnitude higher than record high electrorestriction you would have in an atomic or molecular crystal. So this type of designable building blocks of matter, the knotted objects that because of topological protection have these particle-like properties, can allow us to overcome limitations of natural systems. And this just shows us, demonstrates to us how we could be inspired by the concepts of pure mass to design such objects and then overcome limitations of the natural systems. And so we recently published this highlight article in Nature, where indeed we articulate how we want to go, after these very ambitious goals. So we want to address the challenges of the real world by being inspired and building on the fundamental knowledge enabled by pure mass and knot theory in particular. And so, of course, a very important component of our activities is our effort to contribute to sustainability. And so in here, I just give few examples showing how the concepts enabled by knot theory, topology, and chirality can allow us to contribute to sustainability. And you can see that this range over very broad spectrum related to activities of our WPI Center. So, for example, tangled by polymeric molecules and also crystals formed by catenite or Hopf-linked molecules like the ones in here can allow for forming highly porous materials, and because of that enable very high thermal insulation that's needed to allow for energy efficiency of buildings. Also, another example in here is knots related to proteins, where they can be related to diseases if misknotting of proteins happens. Yet another example is cosmochemistry and super insulating aerogel metamaterials, like similar to the ones we discussed in here, that can allow for super insulation that then could be useful for forming extraterrestrial habitats. And recently, of course, we hear a lot about the nuclear fusion being potentially a future source of green energy. And you might be surprised, or maybe not, that in the facilities like the ones you can see in here that are used for nuclear fusion, you do create knotted magnetic fields in the form of torus knots of different kinds. So additionally, not soliton type of objects can be used to store data and in many other applications, again, overcoming the limitations of more conventional ways of storing energy. And so in all of these approaches, the idea is to start from highly fundamental research, the concepts of knot theory and pure mass, and then based on them, design materials with unusual properties that overcome limitations of natural occurring systems, and with that address real problems of the world around us and contribute to sustainable society. So this brings us to this winter school, where we will try to introduce some of the most important concepts that are essential for us to be able to pursue these ambitious goals. So we'll have a series of lectures and poster sessions, real-time webcast of presentations, and later on they will be organized into archives, and there will be a combination of graduate and postdoctoral level education with learning about the culture and history, being here, of course, related to culture and history of Japan. And hopefully also informal discussions and fun. So in addition to the formal technical program, we'll also have the science communication session that's designed to help our students, postdocs, but also faculty members being effective in communicating their research and hopefully in a way that can attract a lot of attention and therefore enhance the impact of our research as well. And we'll also have a joint research symposium together with another WPI, the WPI-SKCM². What's common between the two different institutes over here in Hiroshima University and the other WPI at Kyushu University is that we have the sustainability focus, and this is why the entire next week will be focused on sustainability related aspects of our activity, and we'll have one-day joint symposium where the research activities of the two centers related to sustainability will be highlighted. So it's not the first time that we organize such winter schools, and for example, many of you, or some of you at least, attended the winter school that we had last year here at Hiroshima University. And in addition to the scientific program, we also had satellite events such as career forums and a career forum, and also an outreach event where we exchanged ideas and best practices of conducting outreach to general public. And so in addition, we will have many other scientific conferences and events, just as we organized in the past. And one that's upcoming, that's also focused on sustainability, will be organized in University of Colorado, here in this campus in Boulder, that will take place from June 1st to June 21st. Again, we hope to see many of you in there as well. In overall other activities, just like the next week program, that's joint program between our WPI and ITUSNER, we are trying to develop synergies in our activities with other WPI. So for example, in organizing the summer school this year, 2024, we partnered with another institute in Hokkaido University, IPRED, where the common research theme was chirality in chemistry. And in a similar way, we will also partner with other WPIs. For example, IMER WPI in Tohoku University. So I just want to highlight a couple different events such as conferences and symposia that we organize, so that you can know what to expect in terms of the spirit of this conference and this summer school, or sorry, this winter school. So you can see here some of the pictures that perhaps tell much more than my words could possibly, right? So in addition to just scientific sessions, we hope to have lots of activities focused on building community, exchanging ideas, developing collaborations. These include things like hikes, for example, as you can see here, an event from our summer school this year, where in Sapporo, we could hike this mountain, this very beautiful view on the city of Sapporo. And also some more pictures from our past conferences and symposia, such as the one in Nara, for example, in here. Hopefully highlighting what we want to achieve during this winter school as well. For young people in audience coming from other places, from outside of our Hiroshima University Center in here, I want to very briefly mention that there are many opportunities for you to join, including applying to our graduate program, including applying for postdoctoral fellowship positions and different types of research exchange opportunities, such as the so-called internship program. So as I already mentioned, we intend to build a community, and we hope that throughout this school we'll have many active, engaging discussions like the ones you can see in these pictures in here. And also, it's perhaps good for me here to brag about the construction of a brand new building for our institute, which started a couple of months ago and will be finished in about a year, in December 2025, right? So you can see in here this virtual walk through this institute building being constructed right now. But I hope that also in future you will be able to visit us in this new building. If you are coming right now from other places outside of Japan, please keep in mind this building will be here, and we hope it will be a global center with a focus on knotted chiral matter with intention to contribute to sustainable future. And I would like to finish with this, I think, very exciting slogan that our institute has. We are masters of the knots, ready to untie mysteries of the world and ready to save the world by solving its knotty problems. Welcome to our winter school, and I look forward to interacting with all of you throughout this program. Thank you.